Welcome to Year 5 Maths Masterclasses. So this masterclass is all about logarithms. So that's quite a long word, quite difficult to say. So we're going to start by looking at indices. So I'm going to put a PowerPoint up and we'll look at some indices and some rules with indices. There's lots and lots of little tasks for you to have a go at. So it'd be good if you could sit down with another member of your family and have a go at those tasks together. Talk about what you're learning, and I hope you enjoy learning all about logarithms. Okay, so we're going to start this lesson just looking at base 2 and 3. Then we're going to look at some rules of indices, then we're going to look at base 10, and we're going to look at what a logarithm is and how we use logarithms. So let's start with base 2. So when I'm talking about base 2, I'm talking about numbers that we can make up by multiplying lots of 2's together. Okay, so what I've got here is 2 times 2 times 2 times 2 times 2, and the answer to that is 32, but I could write it as 2 to a power 5. Okay, so 2 is what we call my base number, 5 is the index number, and lots of these are called indices. Okay, and this means that I've got 2 and I'm multiplying 5 2's together. So my first challenge for you, you might want to pause the video and have a go at that, is what other powers of 2 can you find? So I've given you 2 to the power 5. Can you find some other powers? See how many you can find. When you've had enough of that, you press play and we'll look at a few answers. So if you've had a go, I'm going to write you down a few. So you might have got 2 to the power of 1, okay, which is just a 2 on its own. Okay, you might have got 2 to the power of 2, which we sometimes call 2 squared, which is 2 times 2, and the answer to that is 4. You might have got 2 to the power of 3, which we often call 2 cubed, which is 2 times 2 times 2, which is 8. Then we have 2 to the 4, which is 16, 2 to the 5, which we talked about, is 32, 2 to the 6 is 64, 2 to the 7, 128, 2 to the 8, 256, 2 to the power 9, 512, and 2 to the power 10, 1024. If you've got higher than that, that's brilliant. Okay, well done. Okay, but you can see actually we've only got up to the power of 10, and our numbers have increased very, very quickly. Okay, so what is going on, and can we spot any patterns here? So you might have noticed that actually to get from one number, okay, to the next, we are multiplying by 2. So as that index number goes up 1, we have multiplied by 2. Okay, so to get from 4 to 8, we multiply by 2. So power 2 increases to power 3. So we've got that extra multiplied by 2. And again, multiplying by 2. And again, multiplying by 2. So all the way down, we are multiplying by 2. So if I wanted to look at the reverse pattern, okay, if multiplying by 2 this way, then to go backwards again, I would divide by 2. So 32 divided by 2 is 16. Okay, 16 divided by 2 is 8. And you can see in this case, our powers are decreasing. Okay, so 8 divided by 2 is 4. So we've gone power 3 to power 2, and 4 divided by 2 is 2. Okay. But what happens if I carry that pattern on? Okay, so what if I divide by 2 again? Well, 2 divided by 2 is going to give us 1. How is that going to affect the powers? Well, we've gone 3, 2, 1. The next power we would expect to be 0. So we've got that 2 to the power 0 equals 1. What if I carried on again and divided by 2? Well, if I've got a whole and I divide by 2, I'm left with a half. But how does that affect the powers? Well, we've gone 2, 1, 0. Less than 0 is 2 to the minus 1. So 2 to the minus 1 is a half. Carry on again. Divide a half by 2. So half of a half is a quarter. And this power is going to go down to 2 to the minus 2. And the last one will do, but obviously this keeps going. A quarter divided by 2 is an eighth. And the power is going to be to the minus 3. So we've got 2 to the power minus 3, is an eighth. So that's base 2, and obviously you can carry going on this way and you can carry on going that way. So you might want to stop now and see how many numbers you can find of base 3. So same idea, but instead of 2 times 2 times 2, we're going to do 3 times 3 times 3. So if you want to have a go at that, see if you can get some of these negative powers as well. Okay, when you think you've done what you can, then press play and we'll look at some of the answers. So here we have base 3. So again, we've got 3 to the power of 1 is 3, 3 to the power of 2 is 3 times 3, which is 9, 3 cubed is 27, 3 to the 4 is 81, 3 to the 5, 243, 3 to the 6, 2729, 3 to the 7, 2187, 3 to the 8, 6561, 3 to the 9, 19683, 3 to the 10, 59,049. So again, you can see from 3 to the power 1 to 3 to the power 10, we've increased incredibly rapidly. We've gone from 3 to 59,000 in 10 steps. Okay, all right. So again, what's happening as we go down the list? Okay, well again we can see that every time we go down we're multiplying by another 3. So we've got times 3 times 3 times 3, and that continues all the way down, and as we multiply by another 3 the power goes up by 1. Okay, so again going backwards we would be dividing by 3 and the powers are decreasing as we divide by 3. So again, what's going to happen here? 3 divided by 3 is going to give me 1, and the power is going to become 0. So 3 to the power of 0 is 1. Okay, have we seen something similar to that before? Okay, divide by 3 again, and 1 divided by 3. So if I've got a whole and a divide by 3, that gives me thirds, and the power is going to go down to -1. Okay, and then divide by 3 again, we're going to have a 9th and 3 to the power of -2, and divide by 3 again, we're going to have 3 to the power of -3 and a 27th. And okay, and just look at these denominators here, 3, 9, 27, you'll notice it's these numbers here are becoming the denominators. So the next denominator would be 81, and that would be 3 to the -4. Okay, so you might want to have a look at that pattern and investigate further. Okay, so one thing that we've seen on both is this, both lists have got the number 1 in. Okay, so let's just have a quick look at that. This is quite a key point. We had that 2 to the power of 0 was 1, and we've got that 3 to the power of 0 is 1. And if you looked at base 4, you'd see that 4 to the power of 0 is 1. In fact, whatever number or letter that we choose, if we make it power 0, the answer is always going to be 1. So that's quite important. We're not going to use it so much, well, I might use it a little bit with the logarithms, but it is something that is worth learning. Okay, anything to the power of 0 is 1. Okay, so now we've investigated sort of base numbers and indices, we're going to look at some of the rules that we can use when we're working with index numbers. So there are 3 rules we're going to look at. So just to remind you that these numbers here, we sometimes call them powers or index numbers, okay, or indices, and the larger numbers are our base numbers. So what I'd like you to have a go at is, can you calculate 2 cubed times 2 squared? So you might want to just press pause and have a go. Okay, when you've got your answer then, can you leave your answer as a power of 2? So you might want to just look back at your base 2 numbers and see if you can find which number or which power of 2 gives you your answer. Okay, so hopefully you'll have worked out 2 cubed is 8, 2 squared is 4, 8 fours are 32. But we want 32 as a power of 2. Well, if you look in your list, 32 is actually 2 to the power of 5. Okay, let's look at another one. Okay, if we've got 2 to the 4 times 2 to the 1, okay, again you might just want to press pause to work this out. Okay, so you should have 2 to the 4 is 16 times 2 is 32, and again 32 is written as 2 to the 5. So I've got both these calculations have given me the same answer of 2 to the 5. So what I want to think about is there a connection between the 2 and the 3 and the 5 here, and the 4 and the 1 and the 5 here? So you've probably spotted it already. But on the next page, we're going to look at why that works. Why is it that 3 plus 2 gives me 5 and 4 plus 1 gives me 5? Okay, so on here we've got 2 to the 4, which means I've got 4 2's multiplied together. 2 cubed means I've got 3 2's multiplied together, and I'm multiplying those, which means altogether I've got 7 2's, which is 2 to the 7, and 4 plus 3 gives me 7. Okay, so look at this more generally. If I had 2 to the power of a times 2 to the power of b, okay, the answer to that would be 2 to the power of a plus b. I would add the indices together. So this is the rule. We're going to add the indices together, but please make sure that the base numbers are always the same. So I've always kept this one in base 2. Okay, these two are at base 2 and the answer is base 2. So here are some for you to have a go at. So press pause, have a go. Okay, note that I've always kept the base numbers the same for each question, but sometimes the base is a letter, and that's fine. We've also got some negative indices, so you need to remember how to add negatives and positives. We've also got some indices that are fractions. Okay, they have their own meaning, which we're not going to look at today, but you can use those rules as well. So have a go. Okay, if you've pressed play, are you ready for some answers? Okay, so the first one is the base number is going to stay as 2, and I'm going to do 5 plus 3, so it's 2 to the power of 8. The base number is going to stay as 4, and 7 plus 3 is 10, so it's 4 to the power of 10. Here the base is 16, and I've got 3 plus 1, which is 4. Here the base is a, so the base is going to stay as a, and it's 4 plus 7, which is 11. Here we've got a base of p, and it's 6 plus 6, which is 12. Here I've got a base of 2, and I've got minus 1, add 1. Well, minus 1, add 1 is 0. So I've got 2 to the power of 0, but we've already learnt that that's 1. Okay. Here the base is 4. Now 6 add negative 2 is the same as taking away 2. So that's 4 to the power of 4. Base of 3, a half plus a half is 1. So it's 3 to the power of 1 or 3. And here we've got a quarter plus 3/4. So it's 5 to the power of 1, which is just 5. So hopefully you got those right. And we need to look at rule number 2. So here we have rule number 2. So we've got 2 to the power of 5 divided by 2 squared. So you might want to pause and just see if you can work out what that answer would be. Okay, so 2 to the 5 is 32. 2 squared is 4, 32 divided by 4 is 8. Okay, so how can I write 8 as a power of 2? Well, that would be 2 to the power of 3. Okay, let's have a look at another one. I've got 2 to the 4 divided by 2 to the 1. Well, again, you can have a go at working this out. Okay, if you've pressed play again, 2 to the 4 is 16. Divided by 2 to the 1, which is 2. 16 divided by 2 is 8. And again, 8 is 2 to the power of 3. So again, I've come out with exactly the same answer, okay, but different calculation. So we're again looking, what's the connection between 5 and 2 and 3? What's the connection between 4 and 1 and 3? Okay, so you probably spotted that this first number, take away the second number, gives you the third index number. Okay, but again, note the bases stay the same. So let's have a look at y. Okay, so when we're doing divide, we write it as a fraction. Okay, and 3 to the 7 is 7 3's multiplied. 3 to the 3 is 3 multiplied. And we can cancel out any on the top and the bottom. So I'm cancelled out there, which means I'm now left with 4 3's, which is 3 to the power of 4. And again, you might notice that 7 take away 3 is 4. So this is the general case. 3 to the A divided by 3 to the B is going to be 3 to the A minus B. So in this case, we're subtracting the second number from the first. It has to be that way round. It has to be A take away B. First number take away second number. And again, base numbers have to be all the same. 3 and 3, these have to be the same, and then the answer is the same base. Okay, let's have a go at some. Okay, similar as before, you've got some numbers bases, some letter bases, some negative indices, and some fractional indices. But it's always the first index, take away the second index. So press pause and have a go. Okay, so here's some answers. So the first one, we've got a base of 2. 5 take away 3 is 2, so it's 2 to the power of 2. Here we've got a base of 4. 7 take away 3 is 4, so it's 4 to the power of 4. Here I've got a base of 16. 3 take away 1 is 2, 16 to the power of 2. Base of A, now I've got 4 take away 7, and it's important we do it that way round. So 4 take away 7 is actually negative 3, so it's A to the negative 3. Here I've got a base of P, and I've got 6 take away 6, which is P to the 0, and anything to the power of 0 is 1. Here I've got a base of 2, and I've got minus 1, take away 1 more, which means I've got 2 to the minus 2. Here we've got a base of 4, 6 take away 9 is minus 3. Base of 3, half take away half is 0, which is 1. And then 5 to 3/4, a base of 5, 3/4 take away a quarter is 5 to the half. So hopefully you had got some of those right and you understand what's going on. So now we're on to rule 3. So here we've got 2 cubed, and then we're going to square that answer. Okay, so press pause and see if you can work out what the answer is. Okay, so if you press play, you should work out that 2 cubed is 8, and then when I've got 8 and I square it, I get 64. Okay, now 64 as a power of 2 from your list, you should see is 2 to the power of 6. Okay, so is there a connection between 3, 2 and 6? Have a look at this one. This time we've got 2 squared, and then we're squaring that again. So 2 squared is 4, and when I get 4 and I square it, the answer is 16. Now 16 is 2 to the power of 4. So I've got 2 and a 2. Is there a connection between 2, 2 and 4? Well, let's have a look at the next page. So, third rule here, okay? So I've got 2 cubed to the power of 4. So that's, when I've got power 4, that means I'm multiplying this thing by itself 4 times. So it's 2 cubed times 2 cubed times 2 cubed times 2 cubed. But then we also know that 2 cubed means 2 times 2 times 2. So I've got 2 times 2 times 2, 4 times. So what have I got in total? I've got 4 lots of 3 2's, which is 12 2's in total. So that's 2 to the power of 12. Okay, so because I had 4 lots of 3, that means I've multiplied these two numbers together, 4 lots of 3, to give me 12. So our general rule is, if you've got 2 to the power A, and then you're taking that and putting it to another power B, so with the brackets, you would multiply this A and B to find your new power. So in general rules, okay, we multiply the index numbers, but again, base numbers have to be the same. That's with all the rules. Okay, so have a go at these ones. Okay, remember base numbers are the same and you're multiplying the index numbers. Press pause and press play when you're ready. So very quickly, base of 2, 5 3s are 15, and then we've got a base of 4 and 7 3s give you 4 to the 21. Base of 16 and 3 times 1 is 3. Base of A and 4 times 7 is 28, so it's A to the 28. Base of P and 6 times 6 is 36, so P to the 36. A base of 2 and you've got negative 1 times 3, so that's 2 to the negative 3. A base of 4 and you've got 6 times 3, which is 18, so 4 to the 18. Base of 3, you've got half times 2, which is 1, so 3 to the 1. And here we've got a base of 5 and a quarter times 8. A quarter of 8 is 2, so it's 5 to the power of 2. So hopefully you got those correct. So we're going to move on then and look at base 10. So just like base 2 and base 3, the same things are going on, but base 10 is a lot more useful because our whole number system is based on base 10. So let's have a look. We've got 10 to the 1, which we know is 10. And then we have 10 squared, which is 10 times 10, which is 100. And we have 10 cubed, which is 10 times 10 times 10, which is 1,000, and so on. 10 to the 4 is 10,000, 10 to the 5, 100,000, 10 to the 6, 1,000,000, 10 to the 7, 10 million, 10 to the 8, 100 million, 10 to the 9, 1,000 million, or Americans call that a billion, okay? And then 10 to the 10, 10,000 million. Okay, similar, okay, we are multiplying by 10 going this way, so we're going to be dividing by 10 going the other way. So if we work backwards, we'd have 10 to the 0, and we've learnt that anything to the power of 0 is 1, okay? So in terms of our number system, 1 are our units, then we have our tens, our hundreds, our thousands, our 10,000s. These are the headings for our number system, okay, when you're adding and subtracting. So when we go back again, we're dividing by 10. So 1 divided by 10, okay, is a tenth, or we'd write that as a decimal as 0.1, okay, and the index for that is -1. 10 to the -1 is 1 over 10, or 0.1. We divide by 10 again, we get 10 to the -2, and it's 1 over 100, which is 0.01. And then we have 10 to the -3, which is 1 over 1,000, which is 0.001. Again, so you can see the pattern going on here. Okay, so we're ready to start looking at logarithms. So when we're using base 10, it will work with other bases, but we generally start with base 10 when we're looking at logarithms. It's the index number is called the logarithm. So if we look at the number 100, the logarithm of 100 is 2 because 10 squared is 100. The index number is 2. The logarithm of 1,000 is 3 because the index number, 10 to the power of 3, gives you 1,000. What do you think the logarithm of 10,000 would be? Okay, well it would be 4 because 10 to the 4 is 10,000. What's the log of 10? Okay, well it would be 1 because 10 to the 1 is 10. And just note, I've been using the word logarithm here, and I've shortened it to log. So if you ever hear of logs, actually we're talking about logarithms. Okay, so in a minute when we get to use our calculator, we'll be looking for log on our calculator, but that's the same word for logarithm. Okay, so far this is fairly straightforward. Okay, we've got logarithms of 2, 3, 4 and 1, but all our numbers so far have been powers of 10, 100, 1,000, 10,000 and 10. What if I wanted to find the log of another number such as 2.43? So I'm looking for 10 to the power of something, it gives me 2.43. So before we had calculators, we would work logarithms out using a table like this. Okay, so down the side we've got the numbers from 1 down to 3.3 going up in 1 decimal places or in tenths, and across the top we've got numbers increasing in hundredths. So when I was looking for 2.43, I'd come down to 2.4, which is here, and this would be 2.40, this is 2.41, 2.42, this is 2.43. So the log of 2.43 is 0.3856. So 10 to the power of 0.3856 is the answer, 2.43. So why is this useful? Well, again, before calculators, calculations like this could take quite a long time, okay? And you might even have more complicated calculations like this. And so people used to use log tables to help them perform these calculations. They'd use their log tables and the index rules that we've just been learning about. So if I was trying to calculate 2.43 times 3.29, I'd start by finding the logarithms. So we've just found that 2.43, the log of 2.43 is 0.3856. So 2.43 can be written as 10 to the power of 0.3856. 3.29, if we go back to the table, here's 3.2, 3.29. The log of 3.29 is 0.5172. So 3.29 is 10 to the power of 0.5172. Now we've just learnt that when you're multiplying, doing a multiplication and the base numbers are the same, you can add the index numbers. So adding these numbers is much easier than multiplying these numbers. So if we add 0.3856 to 0.5172, we get 0.9028. So 10 to the power of 0.9028. So now I've got to work out what the answer to 10 to the power of 0.9028 is. So we've got to sort of use our log tables backwards. So in this table, I'm looking for 0.9028. So I've got 0.89 here. If I keep going, I get to 0.90. I've got 900, 901, 902. I'm looking for 9028. This gives me 9025. So if I go to the next line, I get 0.9031. Okay. Now 0.9028 just happens to be halfway between these two. Okay, so 7.99 is a little bit too small. 8.0 is a little bit too big. We're halfway between, so halfway between is 7.995. Okay, so you might want to just do this on a calculator. Type in 2.43 times 3.29. and your answer to three decimal places will be 7.995. The actual answer is 7.9947, but if we round it, we get 7.995. Okay? So that's multiplying. Okay? It'd be good if you could have a quick practice here. So we've got 1.22 times 1.74. Okay? You'll need to find the log of 1.22 by looking it up in here. You'll need to find the log of 1.74 by looking it up in here. Okay, they're now your new index numbers, and then you use your index rule, which is to add the indices, okay, to get your new index number, and then work backwards, find that in here, and work back to the original number. Okay, there's the first question. Second question is a division. So again, find the log of this from the table, find the log of this from the table, write it in index form. This time you're dividing, so it's going to be this index number, subtract the second index number, and then again look for the answer in the table. So press pause, and I'll put the solutions up in a minute. Okay, so here we have the solutions. So the log of 1.22 was 0.0864, so that's 10 to the power of that. And the log of 1.74 was 0.2405. So my index rules say that I can add those powers, and I get 0.3269. And if I look that up, the closest one, it's not absolutely spot on, but the closest one is 2.12 to 2 decimal places. Okay. For the division one, we got the log of 2.01 is 0.3032, and the log of 1.16 is 0.0645. So if I do that subtraction of these two, we get 0.2387 as our log. And again, if we look for the reverse of that, the closest one is 1.73. So that's how logarithms have been used in the past, before we had scientific calculators, or even normal calculators. Okay. So obviously with our calculators and scientific calculators, we don't need to use logs for that purpose anymore. We certainly don't need to do multiplication and division, okay? But we do still use them for other calculations. So the further into maths you get, the more useful logarithms become, okay? But we don't need to use the tables anymore, because our calculators have got very good. We've got scientific and graphic calculators, and they have what's known as a log button on them, okay, that will find logarithms for us. So I'm going to put a calculator up on the screen. Okay, so what I've got here is a Casio calculator, a scientific calculator. There are lots of different ones, but as long as you've got a scientific calculator, it will have a log button on it. So my button is here. Now this button, if I press it, has a little box here to tell me, so I can tell it what base I'm working in. So I'm going to be working in base 10 to start with, okay? If you don't have that on your calculator, if there isn't a box there, it means it's already in base 10, so you don't need to do any more. It will be log base 10, okay? So we're going to start by thinking about the log of a number where we already know the answer. So if I put the number 100 in here, using these arrows I can move into that box. If I put the number 100 in here, we know that 10 to the power of 2 is 100, okay? So the log base 10 of 100 should be 2, and there we have it, okay? Because 10 to the power of 2 gives me 100. Let's try another one. Let's do base 10 again. Okay. Oh, something went wrong there. Let's try again. So log base 10, and we're going to put 1,000 in this time. Okay, so we put 1,000 in. Again, I'm working in base 10, and I know 10 to the power of 3 gives me 1,000. So log of 1,000 should be 3. Okay. Let's have a look at, we'll do log base 10 again. Okay. Let's have a look at the number that we looked up on the table, 2.43. Okay, so what's the log of that? We get 0.3856. Okay, so we did look that up on the table, but we could only do it to 4 decimal places on the table. On a calculator, we obviously get a much more accurate answer. Okay, so if you've got a scientific calculator, you might just want to play around with that, try different logs, see if you can work out what some of them might be. Especially powers of 10, you should be able to work out what those logs are. Okay, if you have got one of the calculators where you can change the base, okay, you might want to look at different bases. So if we put base 2 in there, that was the first set of numbers we looked at. So if we pick a number from our list, let's say 32, okay, 2 to the power of what gives us 32? Well, it's 2 to the power of 5. So the log of 32, when we're working in base 2, should be 5. And there we have it. Okay, so the log of a number is the power for that base. So 2 to the power of 5 gives us 32. So have a play around, maybe change your base to 3, maybe have a look at base 4. Okay, just to finish off then, how would we work out the number if we know the log? So this was one of the questions we did from the tables, okay? We changed this to logarithms, we changed this to a logarithm, okay? We added the index number and we got the number 0.9028, Okay, and then we had to look in the table to find out what number had a log of 0.9028. Well, on the calculator, most of the inverse functions that undo things are found on top of the button that we've been using. So here's the log button. So the button I would use to undo the log would be shift. Now this only works for base 10. Okay, so it's shift and it gives you 10 and then it tells you to put the power in here. So we're going to put 0.9028 in, and if we press equals, we get 7.994666. Now on the table, we had 7.995. Okay, so obviously again the table we were limited to 2, and sometimes we managed to get a third decimal place on this one because it was halfway between, but on here we can get it much more accurately, but you can see that it would round to 7.995. Okay, so again, if I know the log is 5, okay, I'd press shift and log, so it's undoing. If I put the 5 in there, okay, where 10 to the power 5 is 100,000. Okay, but that one, the inverse only works for base 10. It doesn't work for the other bases. Okay, so that's everything on logarithms. If you've got a scientific calculator, you can obviously play around and try different numbers and see, look for patterns. But I hope you've enjoyed that. Yeah, and look out for more maths masterclasses. Okay, bye bye.